Hi, this is Mr. Mitchell, physical science teacher at Coosa High School, and we want to talk a little bit about significant figures. You know, there are rules as to how many numbers you put in your answer, and it's not just random rules. It's not just somebody said, oh, we should stop at so-and-so numbers. No, it's because of precision in measurement. You see, all these formulas that we have are based upon some sort of measurement. For example, if you have this formula, speed equals distance over time, these two calculations, 7.23 meters and 4.16 seconds, are measurements that were taken, or measurements that can only be to a certain degree of precision. This 7.23 is probably not 7.230000. There probably are some numbers that should be after it. But because of what you measured it with, maybe a meter stick, maybe a tape measure, whatever it is, we only know how precise it is to 3 digits, 7, 2, and 3. We don't know what it would be after that. Same thing with 4.16. We only know how precise it is to these 3 digits. We don't know after that. So when you punch in a calculator 7.23 divided by 4.16, you get a whole lot of digits. 1.7379877 meters per second is supposed to be the answer, but it shouldn't be, because we only know to three figures how precise these measurements are. So your final answer should not be any more than 3 figures in this particular case. See what we're doing? We're counting up the number of figures that we have here, and we're going to make sure our answer is not going to be more than that number of figures. So we have 1, 2, 3 figures here. Now keep in mind, I'm going to have to round this 3 up because 7 is higher than a 5, or 5 or higher. So I'm going to say the answer should be 1.74 meters per second, not this long number here. This long number is just what your calculator says it is, but it's not thinking in terms of significant figures. So whenever you do measurements in physical science class, whenever you get data like this, you need to keep the answers in the correct number of significant figures. There happen to be a lot of rules on these significant figures, and the rules happen to be at the bottom here at this tinyurl.com/YY9NQBYA. But I'm going to kind of summarize them right here. If you need to go back to those rules at some point, you're welcome to. Here's kind of a summary. One rule is every non-zero number is significant. So all these 4 numbers, not a one of them is a every one of them are not zeros. So how many significant figures would you have? Well, it'd be 4. 1, 2, 3, 4. They're not zeros. They're significant. So what about rules when you have zeros? Here you have a couple of zeros. Every zero between non-zeros are significant. So are these zeros between significant numbers? Why, they sure are. So you got a significant number in a 2 and a significant numbers in 4 and 3. So how many significant figures are there here? It would be 5, because these zeros do count. Here's where it gets a little bit on the tricky side. If you have zeros to the left of the first significant figure, they are not significant. So how many significant figures would you have here? It would just be 1. But on the other hand, zeros to the right of the first significant figure are significant. Now, here's why this is the case. Because since you went to 2 digits here, that means you had the preciseness to these 2 digits past the decimal point. So how many significant figures are there here? There are 2. And you may say, well, what about this 0? Well, it's to the other side. You may remember that those are not significant. So the 2 significant figures here are the 3 and the 0 that's to the right of the 3. Now here's one that's kind of challenging also. zeros to the left of the decimal, decimal of course is there, are significant unless you use scientific notation. So you have 1, 2, 3, 4, 5 significant figures here. However, since you have a bigger number like this, there is a chance you would call this something like 5.3 times 10 to a significant or a scientific notation power. And we'll count up what that would be. So that is 10 to the 1, 2, 3, 4, 10 to the 4th power. So if it is used like this, then you only have 2 significant figures. So that answer would be 2. Does that make sense? Okay, let's try some. Calculations. Ooh, take a look here. We have 1, 2, 3, 4 significant figures and 1, 2, 3 significant figures. What do you think the rule is? Should we keep 4 or should we keep 3? The rule is the lowest number of significant figures is the one that you keep. So this has 3 significant figures, so your answer, which happens to be this, should not be written like this. It should be in 3 significant figures, 1, 2, and 3. Keep in mind you're going to have to round up the 1 because the next figure is higher than or 5 or higher. So that would be 1.32. I don't think we have any units on this one. Okay, so we have 1, 2. Wait, is that a significant figure? Let's go back and see. Numbers to the right are significant. So yes, that is a significant figure. So we have 1, 2, and 3. In this case, we have 1, 2, and 3. So you know the answer will be in 1, 2, 3 up. So you cannot leave the 2 on there. So this is going to be 9.10 is what the answer will be. So on the last one, let's see what you have as far as significant figures. How many significant figures do you have here? You know you have 1. You know you have 2. Is this 0 significant? No, because it is to the left. The 0 here was significant because it was to the right. But this one is not. So we only have 2 right here. How many significant figures are here? Those 3 are. What about this 0? It is not, because remember, it is to the left. So the least amount of significant figures we have is 2. So our answer should only be as far as 2. So we have a 3 and a 3. And keep in mind this second 3 we are going to have to change to round up. We can go ahead and put this 0 here even though it is not significant. But we cannot have more significant figures than it calls for. So I hope this tells you a little bit about significant figures. We do have some practice down here at tinyurl.com/Y65N65V5. And I hope this was helpful to you. Thank you.